and I need help from you lot, because I tried, and yeah, time got ahead of me. I didn't realise how quick it was. I was trying to find out where we got to last time. And I know that we did a whole load of factoring. Did we actually get to do any of the homework questions yet? That's the question. And the ones I'm talking about are the ones to do with multiplying and simplifying. Did we do any of those, or did we just do the ones I picked? Can anyone help me there? Can you remember?
I think we had just finished right after the X method.
The X method, the magic X method.
Yeah.
Right. But we hadn't done any of the questions straight from WebAssign. You'd only done the ones that I've made up. Does that sound about right?
I think so, yeah.
Okay, that makes sense to me. But it's just hard for me to remember. I guess I'm getting old. Okay, well, that is good. So what we're going to do today, well, we're going to do two things today. We're going to first do some more questions from homework number 7. And that is essentially going to be multiplying. And then we'll get started on, might even get finished, homework number 8, which is how you divide, division of rationals. So, although I haven't got them set up, I do have them, and I'll go find them. Okay, so let's just do a, let's find one. It's not too weird. Okay. This particular one is like question 15, and that's quite a big jump, but I'll be going back to the earlier ones later. So we want to multiply x minus 5 over 5 times 5x over x minus 5. So what we're going to be doing is looking at what happens when you have two fractions and you want to multiply them together, and you, essentially you want to simplify them as well. So what I try to do here is combine all the terms on the top and combine all the terms on the bottom. Now, a lot of people don't need that line, but I like it, because once I've got a single fraction, for some reason in my head, it's easier to simplify it. If I have two fractions multiplied together, I can simplify them, but it just seems a bit easier in my brain. Would you agree that that x minus 5 will cancel out that x minus 5? That's a 1-for-1 deal. Is there anything else in this particular fraction that cancels that's kind of nice?
5. The 5s.
Yeah. Now, when you destroy everything, don't you leave a little 1 behind? It's important to remember the little 1 behind. Now, when we've done everything that can be done, then what's left is the answer, right? But sometimes the answer ends up looking like this. And this is a special case. What is x over the 1 really the same thing as?
Just x.
Just x. So that would be the final answer. Okay. Let's try. This is a version, this is 18. We have x take away 6 over 4x add 12. We're going to multiply it by x add 3 all over x squared minus 36. Now, in this question here, when I put them all together and then simplified, there was nothing else that could be done to any of these terms. That was as good as we're going to get. When I look at some of these terms, especially the ones on the bottom, do you see that you could do a little bit of factoring? So I'm going to go x minus 6, x plus 3. And then I'm going to pull out a 4 and get an x plus 3. Do you recognize a difference of 2 squares here? X squared 30 minus 36. Now that can be factored, and that becomes x plus 6, x take away 6. So as you see, what I've done in this line is I've combined them into a single fraction, and while I'm doing that, I factored each term that could be factored. So once that's all done, can't we start doing the cancelling? This gets cancelled with that. Okay, anything at the top that cancels with anything on the bottom?
X plus 3.
Is there anything else that we can cancel?
X minus 6.
Now, everything on the top's gone, so we put a little 1 there, right? So now what we're left with is a 1 on the top and a 4 lots of x add 6 in the bottom. Now, in this situation here, when the x was in the bottom, didn't the answer change and become a little bit simpler? It was just called x. But when 1 is on the top, it's still there. So that is the final answer. Are you comfortable with it still 1 over in this case, but in this other case, it changes to just x? You see, the 1 on the bottom is different from a 1 on the top. Are we good with that? Any questions? No. Seems to be going good. Okay. This is question 20 then. We have a 3y take away 12 over y plus 9 times y squared plus 9y, and that is going to be over a y take away 4. So let's combine them together as a single fraction. Well, we can't really do much with the 2 bottom guys, so there they are. Can you do anything with 3y take away 12?
Factor out of 3.
Okay, I agree. Can you do anything with y squared plus 9y?
Y plus 3.
Not quite. Y plus, pull out a y as a common factor. Then you get y plus 9. Check it. You see the y plus 9? Pull out a common factor of y. Great. Right. Anything in the top gets killed off by anything on the bottom.
Y minus 4.
I agreed. Is there anything else?
Y plus 9.
Isn't the bottom totally gone? So we remember to leave a 1 behind when everything goes. That leaves me with 3y on the top and 1 on the bottom. Can 3y over 1 be simplified or written in a better way?
3y.
And now we're finished. Don't expect every question to look like these. You realize these are just the beginning, right? They go through little themes where they do certain things that happen. Then we'll see other themes where there's things going to be left on the top and on the bottom, right? So don't expect every situation to have a 1 in it. That would be unrealistic. I would say it's unrealistic. Okay. Z squared plus 4z, take away 5, over 5z, take away 5, is going to get multiplied by 5z, z plus 5. Okay. Is there anything you can do to simplify 5z minus 5?
Pull out a 5.
So it's a common factor of 5. There's nothing you can do with that, guy. So that's the bottom combined, right? The bottom is being factored and combined. Right. There's not a lot I can do with the 5z, so I'm just going to tag it over there. There is something I can do to the z squared plus 4z minus 5. Right? I can factor that trinomial, right? That quadratic. And it's a simple one because it's got z squared on the front. So that means two numbers that multiply together to give me negative 5. But when you add these two numbers, you get plus 4. Who are the two guys that I need?
Positive 5 and 1.
Okay, positive 5. What kind of one?
Negative.
Agreed. Would you all agree then we've combined and factored everything? So if we do that, and we have, isn't the next step a 1-for-1 cancel, as it always is? I'll pick this one. There's a z plus 5 here that will cancel out a z plus 5 here. Anything else?
The
C minus
5
5.
on
D
top.
minus 5.
Cancel out these two 5s. That's one here. Agreed. Okay, anything else? Nope. Let's see what's left over. A z minus 1 and a z. I'd probably put the z at the front just because it looks prettier there. And a z minus 5. And that's our answer. Okay, I'm going to give you the next one. This is 24, or at least one of the questions that are like 24, because WebAssign mucks about with each question a little bit, makes them random. Okay, you got 1 minute. No rush. Factor and put together, and then cancel to get your simplest answer. Oh, forgot my watch. Okay, I think that's about a minute. Done most of the pieces. I just left this thing. X squared plus x minus 30. What two numbers multiplied together give you negative 30, but when you add them, you get plus 1? Two numbers multiplied together give you negative 30, but when you add them, you get 1.
6 and negative 5.
Read? That's the combination. Okay, there isn't too much cancelling, but there is enough. This x plus 6 will cancel out with this x plus 6. And this 5, just the 5, will cancel out with that 5. And what I'm left with on the top is this and this. And what's left on the bottom is this. Are we okay so far? Now I'm going to show you something that we do in the tidying up stage. I call them style points. Anytime you make something look prettier, I just have a made up name. I call it style points. I can make this prettier mathematically. If you have a factor and you're multiplying it by itself, you do that. Does that make sense that x minus 5 times x minus 5 could just be called x minus 5 squared? And that is considered the best version of the answer because it's a little bit simpler, a little bit prettier. Are we good? Right. Okay. Okay, let's go crazy now. Let's do this one together. It's just version of 26. When a question gets ridiculously big and ugly like this one, I add an extra step to my process. I'm not going to try and combine them and factor them at the same time. And the reason why I'm not going to do that is there's just so much going on, I tend to forget to write things down, right? I lose stuff. That's pretty much it. Now, if you've got a great memory, you won't need this middle step, right? But I like it because when it's really ugly ones, and I only use it for really ugly ones like this, it saves me making mistakes. So I'm not going to combine them yet. I'm going to have like an intermediate stage. And what I do in this stage here is I factor everything and I write it down. And then in the next line, I combine them. Instead of trying to write them down and combine them all at the same time. Do you see how it's just too much going on in my head? Right, that's the only reason I do this. You may or may not choose to do this line, totally up to you. So there are 4 things going on here. Let's look at the first term. It's a simple trinomial. 2 numbers multiply together give you -8, and when you combine them, when you add them, you get -7. And my brain is telling me that it's a -8 and a +1. You agree? Okay, next one. Let's look at the bottom. Is there any factoring you can do to 2m plus 12? Even the littlest thing is important.
You could pull out a 2.
Let's do that. Okay, that wasn't too bad. At the top here, do you recognize the difference of 2 squares again? You see the look of it, it's only got 2 guys. It's got some square take away 36.
Plus 6 and minus 6.
Agreed. You all agree with that? Okay, the last one. M squared plus 7m plus 6. Now that's another simple quadratic. Only this time, two numbers that multiply together give me plus 6. And when you add those same two numbers, you get plus 7. What combination does that?
Six and one.
Now, when I put all these guys together, what I was saying is some people can go from here to here and don't need that step. And me, I need that step. You might need that step. And some of you might say, nah, I can keep hold of the stuff. I can keep in my head long enough to get to here. And that's great if you can. I'm pleased for you. But I'm 65 and my brain ain't as good as it should be. That's my excuse anyway. And so I need steps that reduce my chances of screwing up. Okay, it's, oh, this is going to be carnage. I think it's because I'm Scottish that I describe factoring as like battles of things getting killed off. You notice the way I phrase it, it's like there's a big fight going on and a lot of people are going to die and there's only going to be some things left alive. It's kind of that analogy I use, but I've always, I mean, it's probably the way I was taught. We always think of things in quite violent terms in Scotland. So here goes. Anything you can cancel here?
M plus 6.
I can do a 1-for-1 deal.
M plus
Anything
one?
else? I can do a 1-for-1 deal. Anything else? Nope. I can't see anything else. Quite a good battle there, right? Lots of people died. Who made it out alive? Let's say that. That guy. That guy. And that guy. So do you see the process of multiplying fractions, multiplying rational expressions as they call it? Isn't it a process, isn't there? You do this first, then you do this next, and then you got your answer. And if you stick to the process, even the ugliest looking, and look at that, I mean, that's ugly looking, isn't it? Even the ugliest looking multiplication can still be done, can't it? You just don't get overwhelmed by all the stuff that's going on, right? Just take it, okay, I'll factor everything, I'll factor everything, I'll factor that, I'll factor that. But really, isn't that just for very small questions, very small things to do? Take one expression and just factor it. Don't look at anything else. Take the bottom one and factor it. Take the top right one and factor it. Take the bottom right one and factor it. 4 little jobs instead of one really massively ugly. Then stick them all together and cancel. Boom, 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 boom. And then whatever's still left goes in the top, and whatever's still left goes in the bottom. So far, so good. So if I, I'm not doing it right now, but if I give you one of these ugly fonts, do you feel you feel happy about doing it? I'm not going to do it yet, but I will do it later. Okay. I take it back. I thought there was more questions like this that I was going to do. And when I looked at the thing, I bumped into the last question. So you are going to get the last question. Oh, wait a minute. Do you want me to do another one in my own made up versions of this before I give you this one? Or do you feel ready to do this one right now? You want another one of these made up? Or are you good to go? You want to see the last guy?
Let's do one more.
Yeah. Okay. So let's do an m squared minus an m over a 2m plus 4 times an m squared minus 1 on the bottom and m squared plus 3m plus 2 on top. There, there's one. So I'm going to take each one of these fellas, right, and we're going to factor them, right? If they can be factored, I guess. Okay. Can you do anything with m squared minus m? You can. So what is it?
-1 and +1.
Oh, no, that's going to be here. M squared minus m.
Oh, whoops.
Yeah, but you were close. I mean, look at them, look very similar, but not quite the same.
I was just looking at the wrong.
Oh, you're looking at the wrong thing. You were even better then. So that was the correct answer for the guy you were looking at. So back to the other question. M squared minus m. You can pull out a common factor. What is that common factor?
M.
M. I saw you mouthing that at least twice, Rachel. You just didn't have the confidence to say it. You were thinking that, weren't you? You were thinking M. You just weren't quite ready to say it yet. Okay. If you pull out a common factor of M, you will get M minus 1. Are you happy about the M minus 1 that's left when you suck out the M? Right? M away from that, M away from that. Okay, no particular order. 2m plus 4. Anything you can do about that?
It'll be
Pull out a
2.
2.
Yeah. Two people have got the answer. Just call it out, one of you, or both of you in unison if you like. What's left?
M plus 2.
Great. Okay. Simple trinomial on the top, right? What's that? M squared, 3m and a 2. So I'm looking for two numbers that multiply together that give me 2. But when you add them, combine them, you get 3. What are the two guys?
+1 and +2.
And we've already done that one, so difference of 2 squares. Right. So they're all factored. Time for a battle. 1-for-1 cancel. Give me some 1-for-1 cancels.
M minus 1.
M plus 2.
Anything else?
M plus 1.
Oh, I didn't know when I was making this one up in my head that it would come out so nice. But, oh, come on. Is that not pretty? That ugly mess is mathematically just that. Now, you don't need to say, well, I don't think you need to say, when am I going to do that? What is that used to me? That's not what it's here for. This is just to get you to do a part of your brain that doesn't really get used much. You know, you've a big chunk of your brain that's used for language, you know, storing words, storing meaning, communication. But there's another very small part of our brain that is used for abstract thought. How to look at things like hieroglyphics, I guess. The Egyptian probably would be great at this. Hieroglyphics, how to look at symbolic, and how to look at this symbols and these symbols and simplify them. And it just exercises a part of your brain that really doesn't get a lot of nourishment. You know, that little piece of your brain that is there for just abstract thought, right? How you look at things in a totally weird, non-verbal way. And it's kind of amazing how pretty that is. Yeah, that is just pretty, isn't it? You're meant to agree with me. That was pretty. Okay. I don't know how pretty this one's going to be, because some of them are darn ugly even after you've tried to make them pretty. But here is the last one of this type, and then I'm going to go back and do some of those earlier ones that we kind of skipped through. Being the last one in the homework, this guy's pretty darn close to being the ugliest one you're going to see. If not, it is the ugliest one. Okay, I'm going to go and look for my watch. That won't take me more than a few moments. And while I'm doing that, I'm going to say, you have got 3 minutes. Go for it. Well, I didn't find my watch, but I found some water, so I guess that's something. Okay, I think that's probably enough time. Hopefully you got this one under control. There are 4 different things, and I think, yeah, every single one of them can be factored, right? So, no particular order, I'll do it. P squared take away P take away 30. So you're looking for 2 numbers that multiply together that give you negative 30, but when you add them, you get negative 1. You get some version of 6 and 5, isn't it?
P
What's
minus
the-
6, P plus 5.
Great. Right. And what about 3P take away 18? What can you do about that?
Pull out a 3 and then P minus 6.
Agreed. Okay. P squared minus 36. Do you recognize that as a difference of 2 squares? So that's going to be a plus 6 and a minus 6. And this one is just another simple trinomial. So we're looking for 2 numbers that multiply together that give me 36. But when you add those same 2 numbers, you get 12.
P plus 6, P plus 6.
Yeah, roll here today. Okay. I like to put them all back together again. Okay, so it's time for a battle. Who's going to get killed off?
P minus 6 and P minus 6.
Anyone else?
P plus 6, P plus 6.
Agreed. And now we are going to put this whole package together. These 2 guys are going to be on the top. There's going to be a 3 and this guy on the bottom. Right, and finished. Now, when you're doing really ugly ones like this, I've seen this happen, that you do your battle and you cancel, you cancel, you cancel, you cancel, and imagine a totally different question, but you get this. Right, so you write down what's left, and this is what's left. What have you noticed has happened to you?
You could divide the 3 into 6.
And it is-
and
So what that is saying is that I'm not really finished. But now I am. But that's okay. Can you imagine if it was really, really ugly with lots of different factors all over the place, that you might occasionally miss some. But when you write the answer down, well, you just have another, let's just look, one more look. Is there anything that I missed the first time out? And if there is, kill them off, make it even prettier. Anything left over? Nah, I'm finished. Right? So it's just like a little check at the end. It's probably only going to happen now and again that you might even do that. You might never do it at all in this particular bunch of questions. So what's left? Well, I'm going to now go back to the beginning, which was a big bunch of questions that we kind of missed out, and there was all sorts of reasons for me to do that, mostly because there's something awkward about them, or there's something kind of weird that might distract you from the process. And pretty much every single one of them is weird. So here is my first problem. This is question 2, or like question 2. There is no factoring to be done. There is no cancelling to be done. All there's left is to make it pretty. And oh God in Himmel, would you look at that guy? Some expression to the power of 0. Now that is not a normal situation. In fact, I think you're only going to see it once, and this is as you're looking at it, right? That's how rare it is. But before I tell you the answer to this, let me tell you some others. 5 to the power of 0 is 1, 7 to the power of 0 is 1, and x to the power of 0 is 1. Have you ever seen that in Math 94? Did you ever come across that weird result that anything to the power of 0 is 1? Is this the first time you've seen it, in which case I'm telling you something you never knew? Or do you think, yeah, I do kind of remember them telling me that? I need some help here. I'm seeing nothing on your eyes. I got a couple of...
I saw it, it was 30 years ago.
Okay, it was so far and distant past that it's gone. Right? It's like a movie that you saw, but you couldn't tell anybody about anything in the movie. Right? It's a goner, right? Well, you now put it back in your box and say, okay, I believe you, it's 1. Right? So anything to the power of 0 is 1. Right? Now I'm going to do a little proof to you, not that you need it for this result, because you're just going to trust me that anything to the power of 0 is 1, right? Because I told you it is. So let me try and prove it to you now. If I asked you to do 7 cubed divided by 7 cubed, would you agree that if the thing on the top is the same as the thing on the bottom, the answer is 1? Would you agree? Like 10 over 10 is 1, 100 over 100 is 1, 42 cubed over 42 cubed is still 1. Would you agree that is true? Right? Now, do you remember that when you were doing powers divided by other powers, what you did is you took the top power and subtracted the bottom. So 7 cubed on the top being divided by 7 cubed could be written as 7 to the 3 take away 3. And that is 7 to the 0. So doesn't that make 7 to the 0 1? I know if that's a good proof or whether that makes it more awkward in your brain, but if you ever have something, an expression of any kind to the power of 0, we just remember it's 1. That's what it ends up being. Very, very weird thing. Can you see why I didn't do that at the beginning? Because wouldn't you be thinking about it all the way through all those factoring that we were doing, and it would get in the way? And none of the factoring things we did had anything to do with this. Would you agree this is a one-off kind of novelty? It really isn't a big issue. It's something you don't see very often, right? It's just not going to be there. Okay. Now, the next situation is like question 1. 2x cubed y times negative 3 x squared y to the 4 z. Well, for starters, there isn't even a fraction here, right? Because the theme is, you know, multiplying rational expressions, and this is not one of those. This is actually just practice at multiplying the tops together. So they're not going to be this cancels this and that cancels that going on. No, none of that's going to happen. All that's going to happen is, how do you combine this ugly guy with that ugly guy? That's what's going to happen. So let's see what we got. That 2 can be multiplied by that negative 3. And when I do that, I get the number negative 6. You happy about that bit? If I look a little bit further, can this x cubed get multiplied by this x squared? Now be careful. If you multiply x cubed by x squared, don't you just get x to the power of 5? Right. No idea why that went like that. Right. Who's left? Y multiplied by y to the 4. When you combine them, you get y to the 5. Plural little z is on its own, and that's your answer. Do you see in that question, there wasn't any fractions, there wasn't any cancelling. It's not to do with that, right? Okay, now, I am going to well, I've changed my mind. I will show you. I'm going to put together a little fractions way, and then I'm doing an ugly one like that. So suppose you had 5x over y times 3x over y squared. Now, if you put them together, the top terms multiply together, right? So what do I get? I get 5 and 3 gets me 15, and x times another x gets me x squared. And then the bottoms get multiplied together, and that's 3, and that's y cubed. But that's all there is. In that question, oh, wait a minute, that's not all there is. I take it back. Can't you now cancel just a little bit? Not much, but is there something on the top and the bottom that can be cancelled? I put my circle too early. 15x squared, 3y cubed. Is there something on the top and the bottom that you could cancel?
15 and 3.
Yep. And when you do that, you get 5x squared left and 1y cubed. Now that is the circle. Okay, let's put one of these ugly guys and one of these guys together. So suppose you got 3x squared y over 4xy times 2x cubed yz over 6xy cubed. So we are going to multiply those guys together and simplify. And they're different from the usual questions because there is no factoring. If you notice, you don't factor anything here. That's not necessary. These are different. What you do in these questions is multiply everything on the top together, combine them. Then multiply everything on the bottom together, combine them. And then we'll worry about simplifying later. So here goes. 3 times 2 gets me 6. X squared times x cubed. When you multiply them, get you x to the 5. And there's a y and a y. So I get y squared. And a poor little z on its own is there. Are you happy about these two top guys get me that? Right, the 3 and the 2. The x squared and the x cubed, the x and the y and the y, and finally the z still. Right, on the bottom, I get a 4 and a 6, which I get 24 when you do that. I get an x and an x, which is x squared, and I have a y and a y cubed, which is y to the 4. So these two guys now become 1. Are we so far so good? You happy about how all the pieces have been combined as you multiply through? Now, the cancelling here is a little bit different, but it's still called cancelling. That's 6 and that 24. Can't I divide both of them by 6 and get a quarter? What happens when you cancel an x to the 5 on top with an x squared on the bottom?
You're left with x cubed on the top.
Oh God, I put it in the wrong place. I'm glad you said on the top. Yes, x cubed on the top. There's that 4. Okay, I have a y squared on the top and a y to the 4 on the bottom. What happens when you cancel those guys?
Y squared on the bottom.
Agreed. What about the poor z? What happens to him?
Stays on top.
Now, that is the answer, and I don't need to do another one, but because I made that horrible blob, that's what I should have had, right? We're finished. Do you see that these kind of questions are a little bit different from the stuff we did at the start of today, right? The main difference in my brain is you don't factor out anything, right? You don't have a difference of 2 squares and factor it. That's not what you do. Don't you just multiply things together and combine them and then cancel at the end? So it's a slightly different kind of way of approaching the problem. Now, I'm giving you this one as an example of a stupid question. This is repeat it, a stupid question. And maybe you'll see in a few moments why it is a stupid question. Right. Do we need to factor anything here? No, I can't see anything to factor. So shouldn't I just combine them and then see what happens? Well, if you put the top row together and put the number at the beginning because it looks good, would you agree that's what it looks like when you put them together? And now why it's a stupid question, in my opinion. Can you cancel anything? No. Isn't that as good as that answer's going to get? And I don't like questions where you don't end up doing anything. I really didn't do anything there. Couldn't have just left the damn thing like that and it was just as ugly. I mean, there's no real benefit. Okay, I might have, I don't know, missed an extra line or so, but not worth the effort. Would you agree? That's just a dumb question. And there are some questions where nothing cancels. Right? You could spend all your time doing all those, difference of 2 squares and trinomials on the top and common factor in the bottom and maybe another difference of 2 squares on the bottom, right? You do all that hard work, right? You put it all together and nothing cancels. And you'll think to yourself, well, that was a bit waste of time. That's 10 minutes of my life I'm not getting back. I don't like questions like that where there's nothing else, when you don't end up doing anything useful. I like the question, like my friend that's gone now. Remember the E/2 one or whatever it was just so pretty. Because at that case, I say, oh, well, that was worth doing. Look how nice the answer is now that I've done that. But here, I do all this work and I get nothing for it. So I don't like that question. I guess it's easy, right? Would you agree? You're done, right? There's nothing else to do. So maybe that's its only saving grace. No, that's about it. Oh, okay. I take it back. There is one last version of these kind of questions that we're going to do. And it's question 14. And it's x cubed y over z times x z cubed over x squared y squared times yz over x y z. I want you to multiply everything in the top together, put it there. I want you then to multiply all the terms in the denominator and put them there. And then do a cancel thing and get the answer. And you have got, I don't know, you get 2 minutes, go for it. Okay, I'm about ready for this one. Okay, someone go for it. Somebody tell me the top row. Everything, X, Y's, and Z's. Everything. Who feels up for it?
I don't know if I got it right, but I put X to the fourth,
Yep, that's
Y
correct.
to the second,
Yep,
and Z to the fourth.
correct. Okay, someone else now. Give me the bottom. X, Y's, and Z's. Who feels up for the bottom? Somebody else. Okay.
X3,
Correct.
Y3,
Correct.
Z2.
Z2. You said Z there. You're not pronouncing it properly. I had to get that in. Come on. Z, remember, it's Z. Remember that new letter of the alphabet that I've introduced to America called Z? It's Z. It looks like a Z, but it's really a Z. Okay. Would you agree that we can now do the cancelling thing? Okay. If you do 4 on the top, right, and an X cubed on the bottom, they do cancel out, and don't you get an X left on the top? Oops, it went red. Y squared on the top, Y cubed on the bottom. How's that going to end up? Who's going to win that one?
Y on the bottom.
Agreed. A Z to the 4 on top and a Z squared on the bottom. Who's going to win that one?
Z on the top.
And she said Z. Did you all hear that? Z. Z squared. You'll be able to go to Canada now and you'll sound like a local. I think they say Z as well. Okay. Finished? Agreed? Done. Getting distracted here. It's not anything you've done. Just getting some stuff set up here. Which we'll have in a moment. We're about to start our next section. Just making sure it's in. Here it goes. Okay. It is homework 8. Good grief, it's through a lot of paper, don't we? Homework 8. We're going to divide rational expressions. Okay. So first thing I'm going to do is magic, and you just have to accept that it works. Somewhere in your life, I hope you were told that when you were dealing with, fractions with numbers, that if you were being asked to take a fraction and divide it by another fraction, it was easier to turn it into a multiplication that got you the same answer. Can you remember that rule? And it was just a weird rule, and I don't know how it was mentioned to you. Essentially, don't you turn the second fraction upside down and it becomes a multiplication? Have you ever seen that rule where if you want to divide by something, you multiply by its reciprocal? It's how mathematicians say it. Human beings would probably say you multiply by the upside down guy, right? So you turn them upside down and you are good to go. Now, in this case here, you get 6 over 4, and then you could cancel that down, and there would be your answer, right? That's the piece of magic. We are going to use that same principle, that same piece of magic to divide fractions. But fractional expressions, right? Things with X's and Y's and Z's and W's and who knows what else in them, right? So you just have to remember that piece of magic. The good news is that 90% of what we need to do, we already know how to do. So let's show you x squared take away 4 over x minus 3 is going to be divided by x minus 2 over x squared minus 4x minus 3. Yeah, that'll do. Guess I should put brackets around everybody. I'm going to do it to one, I should do it to all. So that's a pretty decent fractional question, right? It's not a simple one. So what do I do in step 1? Is I'm just going to keep it simple. So I'm going to leave everything alone, right? I'm not going to touch it. All I'm going to do is multiply by the reciprocal. Turn the second one upside down. Now, aren't you looking at multiplying two fractions together now? Don't we know how to multiply two fractions together? We've been doing these bloody things for a week now, right? We should be really good at them. So shouldn't I just continue the process the way we've done today, right? Factor everything, put them together, cancel, right? So let's do that. X plus 2, x take away 2, because that gives the difference of two squares. X minus 3, because there's nothing you can do to that guy. X minus 2, there's nothing you can do to that guy. What can you do to x squared minus 4x minus 3? Because you can do some stuff to that, right? You can factor it. Oops, my apologies. Now you can do something to that guy. Two numbers multiplied together give you plus 3, but somehow when you add them, you get negative 4. That is doable.
Plus 1 minus 3.
50% right. See, if you multiply those two together, don't you get negative 3? And if you add them, you don't quite get negative 4. Just make a tiny little change and you'll be good to go.
Oh, the plus 3, not plus 3. Minus 3 plus 1 is switched it over.
Switch it by making them both minus.
Um,
Do you see? Minus 1 and minus 3. Right. Yeah, I mean, you got the numbers right. You were just trying to figure out which ones went where. Negative 1 and negative 3, don't they two give you plus 3 when you multiply them, but negative 4 when you join them? Right. Time for some battles. X minus 3 cancels out with an x minus 3. X minus 2 cancels out. When everything goes, remember to leave a 1 behind. So it looks like what we've got left is an x plus 2 and an x minus 1 all over 1. Special case, what do you call it when that happens? What do I write down next?
Don't you just take out the 1?
Yeah. Don't need it. In fact, isn't the answer not even a fraction anymore? We go with that one. Turn me upside down, and then it's a multiplication. So 90% of what you're going to do, you already know how to do. Right? You know how to do the multiply stuff, right? The factor all the bits, put it together, cancel, right? You know how to do that. You've done plenty of that. All you need to do now is one extra step at the beginning. Take the second guy and turn on to his reciprocal. Try that one. Oh, excuse me. Don't get quite as many as these guys, but I'm trying to find the darn thing. Aye, there it is. I knew I had it. There it is. Good. I knew it was somewhere. Okay, this is like question 6. Right, do you see my step 1? Turn this guy upside down and multiply. Here's the line I like. A lot of people choose not to do this line. Okay, x squared, take away 25. Do you see a difference of 2 squares there? Now let's put Don on this hot seat. Don, x squared minus 25. Do you see a difference of 2 squares there?
Yes, x plus 5, x minus 5.
You nailed it. Okay. Francis, put you in the hot seat. See this 3x plus 5? You can hear me?
Yeah.
Right, okay. Let me phrase it in a very particular way. First, can I change it to 15? Because I went and misread the question. So for 3x plus 15, can you take out any common factor?
3.
I agree. If it had been 3x plus 5, wouldn't you just write down 3x plus 5 because you can't do anything to it? Right? Some things you can't do things to. Okay, you put that package together. A lot of people don't need that line. They go from here to here. And I'm okay with that. I mean, you've got young brains, you don't make the same mistakes I do. But if you're a bit, there's something comforting about splitting it into smaller chunks, I guess, right? So you decide in your brain whether you need this line or not. That's totally up to you. In an exam, it's totally up to you whether you write it or not as well. Okay, we got to this stage. So Sarah, going to put you in the hot seat. Can you tell me anybody in the top that's going to cancel with anybody in the bottom?
We're going to cancel x plus 5,
Okay, since I've got you, is there anything else?
and x minus 5.
And didn't we get quite a pretty answer then?
Yes.
Yeah, would you agree that's quite a nice answer? A lot better than that, right? It's quite a pretty answer. I like pretty answers. Do you feel ready for one of your own now? Because there's not really much except turn me upside down and multiply, right? You ready for one? You want me to do another one, or you feel you want to see get your teeth into one of your own? What do you want?
I'm
I got a
ready.
nod. You're ready. Good. Okay, so let me pick one. There's not as many questions in this section because most of the stuff you know how to do, so we'll just be repeating ourselves. So which one am I doing? That's a good question. Okay, there's your guy. Okay, I think we're about almost done. Okay, so it's going to be x squared take away 49 over 3x 21 multiplied by, turn them upside down, and you got that. Okay, that was easy part. There's nothing I can do with these two guys, so I'm just writing them down. X squared minus 49. I'll take a volunteer for that one.
X plus 7, X minus 7.
I hope what is happening in your brain here is, and it's just experience. See, the more of these damn things you say, isn't it easier and easier to recognize them and get the answer? Right? So at the beginning, you're a bit rusty and you're not quite sure what the heck's going on, but hopefully by now you're saying, yeah, that's an X plus this, X minus that. What about this fella, which is actually a common factor, isn't it? What could you pull out of 3x plus 21?
Pull out 3 and then X plus 7.
Yes. And I'm doing this line because I like it. And time for a battle. What can cancel?
X plus 7, X plus 7, then X minus 7, X minus 7.
And when we do that, we're left with an X plus 7 on the top and a 3 on the bottom. And that's a much prettier answer, isn't it? It's much nicer looking.
I don't get why when I'm in class, things click and make sense. And then when it's homework time, my brain just goes to mush and I can't get it right. I don't know.
Oh, that's not uncommon. You're not different than a lot of students. I'm not quite sure what it is. Sometimes it's just you get into a flow, right? You do 2 or 3 questions and there's a kind of flow to it. And then the next question comes up and it's still that flow. And so, you know, it's making sense as you're doing it. And then you have like a couple of hours off or a day off or something. And your brain has had plenty of time to take all that nice thing that you understood and like shuffle it like a deck of cards and screw it up in your brain. So you're not quite as sure how to do one step to the next. I don't know if that's a good analogy or not, but it does get easier, right? If you do enough questions, do as, you know, if you have time, go to the ebook and go to the exercises and just do more of them, right? Just pick questions your own. The answers at the back, at least the odd ones I believe are at the back. Check them. Just do as many as you like. Keep doing it until, you know, nobody thinks about 3 times 2 is 6 anymore, right? But I bet you when you were learning your times table, wasn't it sometimes not as obvious, right? You hadn't reached that practice level where it became obvious. So these are like very advanced versions of multiplication tables, right? You do enough of these damn things, it starts becoming obvious what you need to do in each of the situations. But you think about it, how many situations are? You can't do anything, so you just write it down again, right? It's a common factor. It's a difference of 2 squares, or it's some kind of bloody trinomial, right? An x squared plus 4x minus 10, right? That kind of thing. And for each one of those, you can factor it in a certain way. Well, I'm now going to scare you. I hope not too much, but question 11. I'm doing this one. But this one is a division question on steroids. Oh, shooting space. Me and my scanning.
Is that
The-
last number 26 or 24? Oh, 24.
This,
Yeah.
yeah, both of these are 24s. Now, whoa. I'm going to take the first fraction and do nothing at all to it. Yeah. And all I'm going to do is the magic, right? Turn the second fraction upside down. I feel for many students, if you break it down into smaller chunks, it's just a little bit less stressful, right? It's a little bit easier if you only have to think of one thing at a time. So this is the only thing I thought about. You see, I just turned them upside down. Didn't do anything else. Now the killer one. Each one of these guys, could probably put brackets around them. Each one of these guys is going to get factored. Right? So that's going to be our job now. X squared, take away 2x, take away 48. Now, because it's got an x squared, we call that a simple trinomial, right? So we just need to use the pattern of the rule. Two numbers that multiply together give me negative 48, but when I combine them, I get negative 2. And there is nothing wrong when you getting a bit of scrap paper, like I'm doing right now, and just playing about with some numbers. Right, so I might say to myself, well, 4 times 12. Nah, I'm not going to
I can
get 2
tell
out of them.
you.
You know it?
Yeah, I just did it.
Okay, tell me who it is.
8 and 6.
So you're going to look at that and you say, okay, 8 and 6. Oh, they could be different by 2. And I'm assuming you're going to pick that choice, right?
Yep.
And hey, got it. So you go both over here and you say, okay, it's a minus 8 and it's plus 6, right? I don't need to see that bit, right? That's something you throw away when you're finished. All you need to remember to write down is this bit, right? Okay, there's one out the way. 3x squared plus 27x. What can you do with that guy? 3x squared plus 27x. What the heck is he?
You can pull out a 3.
You can. Can you pull out any more than a 3? Because it is a common factor.
Oh,
3x.
X plus, oh, 5.
Right, you can pull out an x, correct? Now, when you pull out a 3x as a common factor, when you pull it out of here, you're left with an x. And what happens with the 27x? What happens there? What do you get left behind?
9.
Agreed. Are you happy about this one as a common factor? But the one above it was what a simple quadratic. Okay, what about 6x squared plus 24x? Is that a common factor or is that one of those trinomial things? 6x squared plus 24x.
It's a common factor. You can do 6.
How do you know just by looking at it that it has to be a common factor? It couldn't be the other one.
I can't
What's the-
remember the numbers.
What-
Oh, sorry. I was thinking of only 24 and 6. You can do 6x. Sorry.
Oh, you tell me the answer. None to be sorry about. What you got here is, do you notice there's only 2 terms? If you're a trinomial, which is another name for a quadratic, don't you need 3 things? So if I see 2 things, I'm thinking common factor. But if I see 3 things with an x squared, say I'm thinking of trinomials. Right. Okay, you were choosing numbers there, I think. So 6x, agreed? What's left when you pull out a common factor of 6x from these 2 terms? What do you get left at the beginning there?
You get x plus 4.
And that's that one done. Now, the guy at the bottom, trinomial. Vanessa, I'm going to put you, poor soul, in the hot seat. 2 numbers that multiply together give you positive 24. And when you add these 2 numbers, you get 10. So who in the heck are they?
Oh, 4 and 6.
Oh, you did it like it was an easy question. You nailed it. Exactly. Okay. Now, I like to put things together. I don't know If you do, it's okay if you don't. Okay. Actually, if I was thinking about it, shouldn't have stuck that 6x at the front because it looks prettier, but that's not a big deal, so I'm not worried about it. Okay. Is there much in the way of killing going on here? Can you see in and cancelling with something else? John, can you see any cancelling in this lot?
X plus 4.
Nice, agree. Anything else going on? Because I can see something else.
You can simplify 6x and 3x.
And if you do that, you're left with a 2?
Yep.
Yep. Okay. I'm asking this even though I kind of know the answer. Is there anything else I can do? No.
Cancel X plus 6.
Oh, I said no, and I was wrong. I was wrong. Right. I missed it. But that's a good thing. I'll show you in a minute how that's a good thing. Oops. Right, I'll now ask that question. And now I really am sure I know the answer. Is there anything else I can do? No. When you reach that point, you then just take what's left on the top and take what's left in the bottom. And you're finished, right? Can you pretend for a minute that I missed the x plus 6? Because I definitely could have. That would have been the guys on the top. And this would have been the guys on the bottom. And then I would have said, oh, I missed that guy. And I still would have got the right answer. So it's not the end of the world, right, if you miss one, as long as you find out later on that you missed it and cancel it again, right? You know, sometimes you take a fraction, I'm making this up, but you take a fraction like 50 over 100, right? And you divide top and bottom by, say, 25, and you get 2 over 4. And then you go, oh, wait a minute, I can do better than that. Isn't it a bit like that? Where you simplify something down, but you realize you can do it even more. So that's okay. That wasn't a killer, right? I mean, I could fix it. It's not a big deal. But would you agree that's a pretty massive question as well, isn't it? There wasn't a lot of, there wasn't a 2-minute question. Okay, now I want to show you even uglier than that. This is the ultimate worst division question. It is that bad. I probably wouldn't even give you it in a test. It's that hard. I don't think it would be fair to give you in the test, but it's always good to stretch our brains, right? So here it goes. It's a 5x squared, and add a 42x, and take away a 27, and it's over x add 9. And it's going to be divided by a 5x squared, a negative 48x, and a plus 27. And that guy's going to be x minus 3. And all I'm going to do in this line is turn the second one upside down. And the ultimate horrible factoring, it's one of these guys. So I'm going to get a bit of square paper and I'm going to go over here and I'm going to focus on just factoring this guy. Do you recognize it's going to be One of them. You agree? Okay. So what do we do here? How do you set this damn thing up? You've forgotten? Okay. Let's find out how good your notes are. I'll give you 2 minutes to see if you can find out how to do the magic cross method. Because if I just tell you, it won't stick as much. But if you go and find it, you'll probably remember it better for the next time.
Take the 5 and multiply it by 27.
And what do you get? 135. Where do you put it?
The bottom.
Oh.
Top.
Oh, I'm not going to do if it's wrong and then you keep doing it until I say it's right. No, no, no. We're not doing that. You don't tell me anything until you are ready.
On the top. Final
On the
answer.
top. Final answer, just like in the quiz show. So what's that, 135? Or negative 135?
Negative.
Okay.
And then 42 on the bottom.
Okay. Okay, we get some more numbers to get, haven't we? So what are those numbers going to be?
Divided by 4. Or no, never mind, sorry. I don't know.
Okay. I think this is a good point for me to do something. Right, let's just pause for a minute. You don't get many magic cross questions to do, but it's one of those situations when you do get them, if you don't know how to do them, right, that's pretty much the question's over then, right? Because you don't know how to factor it, how you're going to get the answer, because that's going to be a biggie. So I'm trying right now, very badly. Oh, I thought I'd set it up. Never mind. Hold on a second, guys. I am going to. Oh, darn it, in space, where are you? You can tell I'm getting tired. My brain's going sponge. Right. Okay, I think I'm ready. I'm never sure with this thing. Hey, where are you? Are you looking at Math 99 Canvas? Good. Right, so I'm now going to go down to, where is that? That's mine. I put it, where did I put her? There we are. Remember this young lady? If you haven't used her video, if I click on this one, you'll say hi. And if we go, I think it's about here. Oh, a little bit too much. Right. I know you can't see the sound, but we're just going to watch her video for a minute. And oh, no, forget it. That one's got a common factor. I have to go further. Yes, this is one with a cross in it. So there's the cross. Now she's going to tell you some magic. She's going to tell us that you take 3 in the -8. She goes. And we got that bit already set up, and that's going to be -135. Well, in her case, it's 24, right? But that's what those two numbers multiply. And then the bottom number she's going to show us is 10. And just like you said, that went to the bottom, so you were bang on. You got that bit. And then we said, oh, well, what do we do about, you know, the rest of it? So we're looking for two numbers that multiply together. They give you negative 29. And when you add these two numbers, you get 10. Or in her case, 24, by the way, sorry. I keep saying 29, but her 4 looks just as bad as my 4s. My 4s look like 6s, her 4s look like 9s. Can you see it's 12 and 2? Does anybody know what the next step's going to be? What are you going to do with that 12 and 2? Because we're almost finished. There you go. And then you simplify the 12 over 3 to 4 over 1. We don't care about the top and bottom numbers now, they don't matter. You can write them if you like, but they don't matter, so I wouldn't bother. And that guy becomes 4 over 1. And this other guy becomes negative 2/3. And those two numbers tell you the factors. So she's going to write them down. So the 4 over 1 is going to give me something, right? And the 1 tells me the x's. So that's 1x. And the 4 tells me what to put next to it. So 1x add 4. And then the next one is going to be 3x minus 2. As it came back to you now, the magic cross method. But that, don't feel too bad that you didn't remember it. What did we do? About 3 or 4 questions. We didn't do a lot. And it's